Okay, start recording. We will continue with statistic 2. Okay. So chapter 4, okay, population and sample. Population, sample. Okay. So the first part we already done, which is a sample. Okay, the first part already done. Now we need to go for the second part, estimation. Okay, now you need to go for the second part, estimation. What does it mean by estimation here? Estimation here is actually talking about if I have a sample, okay, that actually extract from the population, okay, is this sample good enough to representing the population? Okay, if this sample good enough to representing the population. Over here we have two formulas that students need to know. Okay, so over here let me crop the formula. Okay, we call it, so number one we have unbiased estimator for population mean. Okay, so over here we say that expected of EX equals to mu. Okay, expected of EX equals to mu. Then that means it's from your mean value. Okay, it's from your mean value. Then we have unbiased okay, the screen's off. Wait. Unbiased estimator for population variance. Okay, so we have S squared equals to 1 over x equals to sum of x over n. This is 1 over n minus 1. Okay, the formal definition will be sum of x minus bar x squared. Okay, this is a formal formula. Then we also have a simplified formula, 1 over n minus 1. Okay, sum of x squared minus sum of x squared over n. Okay, so you also have this relationship here. So both of these formula you can actually found in the MF19. Okay, inside MF19. Okay, the proof for this formula, okay, we will discuss when we enter further stats later. Okay, but what you need to do is actually understand the how to actually use the formula for now. Okay, let's see. Okay, so let's look at our calculator as well. Okay, let's see. Example 1. The number of passengers traveling on an executive jet on a random sample of 10 Okay, journey is given below. So this is a sample. So 528335130 Okay. So okay. So there will be 5 passengers in one of the journey. There are 2 passengers in one of the journey, and so on. Find unbiased estimates for the mean and variance. Okay. So they are just, but technically they just ask you to use the formula. Okay. So bar x equals to 5 plus 2 plus 8 plus 3 plus 3 plus 5 plus 1 plus 3 plus 0 plus 4 over 10. Okay, of course, at the same time, you actually can use from the calculator as well. Okay, what you can do, you can actually go to the statistic mode, one variable. Okay, you key in the data inside, 5 equal 2 equal 8 equal 3 equal 3 equal 5 equal 1 equal 3 equal 0 equal 4 equal. Okay, then you press options. You press one variable calculator. Okay, so you will see that this value is 34 over 10, then you have a 3.4. Okay, now we want the estimates. Okay, as for the variance, so as square. So I will have a 1 over 9. Okay, or summation of x squared, so 162 minus 34 square over 10. Okay, so you get a 5.155. Okay, so you can see that from this working. Okay, this one you actually can get from your calculator. This is a S2X from your calculator. Okay, you can see the button if you key it better inside the statistic mode. Okay, then from here, let's see for other example. Okay, let's try to look at other example. The weight in kg, okay, to the nearest kg of a hand luggage of a random sample of 10 passengers traveling on a long haul flight are given below. So okay, this is the kg, 8 kg, 7 kg, 9 kg, and so on. Find the estimates of mean and variance, okay, for the weight. So again, you are actually key inside do your calculation. So sum of x over n. Okay, so I clear my memory. Okay, shift menu. Okay, shift 9. Set memory, just memory, yes. Okay, option, select type, one variable. So I have 8 equal, 7 equal, 9 equal, 10 equal, 10 equal, 8 equal, 4 equal, 7 equal, 9 equal, 10 equal. Okay, so I have the value options, one variable calculator. So I have 82. 82 over 10, so I have 8.2. Yep. Then you have s squared, okay, 1 over 9. Okay, so I think I better write out the formula first. Okay, 1 over n summation of x squared minus summation x, the whole thing square over n. So I have a 1 over 9. Okay, so 704 minus 82 square over 10. So you have a value of 3.511. Okay, so you have 3.511. So you are expected to remember the formula. Or if you can't remember the formula is given inside the formula booklet. Okay, let's go for more. Okay, then what if you have this question, example 3. Okay, wait, where Okay, what about we have this? Let's say we have this question, example 3. Okay, so this is a continuous data. Okay, the mean weight x of the random sample suitcase in the long, okay, given as this. So first of all, we have to calculate the frequency. Okay, so we also need to have a midpoint. So we have a midpoint value, midpoint. Okay, so I have, let's see, reset. Okay, menu, statistics, one variable. Okay, shift setup, frequency on. So I have supposed to have midpoint, so midpoint 4.5 plus 9.5 divide 2. I have a 7. Okay, and then I have a 9.5 plus 14.5 divided by 2. I have a 12. Then I have a 14.5 plus 19.5 divided by 2. I have a 17. And I also have 19.5 plus 24.5 divided by 2. I have a 22. Okay, then I also check on the total frequency of 5, 9, 35, 24. Okay, so what do I get here? For I have total of 73. Okay, so I want to calculate mean. Okay, so sum of fx over sum of f. So I will have a 1266 over 73. Therefore, I have a 17.34. Then I have a s squared equals to 1 over sum of f minus 1. Okay, I have a sum of fx squared minus sum of fx, the whole thing squared, over sum of f. Then I have a 1 over this one 72. Okay, I have 23272 minus 1266 square over 73. Okay, let's see what do I get. Okay, manual calculation. Okay, 1266 square divided by 73 minus 23272 minus, okay, divided by 72. So I have a 18.28. Okay, as your answer. So by now you should have an idea about how to actually get the answer, okay, of your calculation. So next one, we want to look at some other formulas that you are expected to know. Okay, so you need to learn something called confidence interval. Where is the thing? Okay, you need to learn something called confidence interval. CI. Confidence interval. Okay, CI. So, although that we are using a sample to estimate for the population, okay, although we are using sample to estimate for the population, but the result that I get will have a certain interval. Okay, so there is a certain variations of it. Okay, so we have to know how to actually deal with this calculation. Okay, there will be a few formulas that you are expected to know. Let's see. let me crop out some summary. Okay, so that you actually know what is it about. Okay, let's continue. Okay, so this one is confidence interval for mean. Okay, so this one, the first one is called CI for population mean. Okay, so representing by mu. So the calculation is by using bar x. Okay, bar x is a value that you actually get from your sample, value that you get from sample, okay, minus, okay, this one I'll write as z of alpha over 2, okay, of sigma over square root n, okay, bar x plus z alpha over 2 sigma over square root n. Okay, it's an interval. Okay, so the alpha here, let me crop better. Okay, so 1 minus alpha times 100% CI for population mean. Okay, so this is how it looks like. Okay, so it's so 1.96 here is actually corresponding to 95%. Okay, so 1.645 is 90%, 2.326 is from 98%, 2.576 is from 99%. Some students will say that how are we expected to actually remember these values? Actually, you don't. You actually refer back to your MF19. Okay, use MF19. Okay, so from underneath the normal distribution table, okay, there is a small table. The small table is the one that actually gives you these values. Okay, so let's see how do we actually do it by using examples. Okay, let's see. Okay, example form. Let's see. Example 4. The weight in gram of bags of coca beans are known to have a standard deviations of 6. Okay. So this one here means that saying that population variance is given. Okay. Then a random sample actually gives us this value. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So n equals to 10. So I need the bar x value. Okay, I need the bar x value. So I add the value up. Okay, 758 plus 748 plus 749 plus 752 plus 757 plus 760 plus 751 plus 745 plus 759 plus 761. Okay, so I have a 7520 divided by 10 as 752. Okay, calculate 95% CI. So 95% CI for mu will be equals to, okay, bar x plus minus, so 95% will be 1.96. Okay, so where is this 1.96 from? So 1.96 here. Okay, then multiply by sigma over square root n. So I will have 752 minus 1.96 times by 6 over square root 10, comma 752 plus 1.96, 6 over square root 10. Okay, so all you need to do is just apply your calculation. So 1.96 times 6 divided by square root 10, okay, minus 752. So I have a 748.28, comma, plus 752 plus 752. I have a 755.72. Okay, so I have this value. So this will be my uh, 95 CI for 95% CI for mu. Okay, so remember from the previous lesson we learned about CLT. Okay, CLT for a large sample n greater than 30 for any population. I don't care. Okay, so the if the variance is given, then we use here sigma. If this is not given, okay, if it's a not given, or have to be estimated, not given, okay, then you have to use S. Then your S is from here. Okay, from S is from here. So this is actually from CLT. Okay, if it's normal, originally it's normal, then you don't need to. Okay, so how do I actually look at the example? Let's see. Okay. This one, where is my screen? Okay. The weight X in gram of a random sample of 50 adults, okay, n equals to 50, following the summary statistic as this. So I don't know the population distribution. We don't know. I don't know what is that, but they give us these two information. Okay, these three information. N equals to 50. Sum of x equals to 10003.3. Sum of x squared equals to 2002665. So over here, it tells us that population variance is not given. Okay, that means we need to use S. Okay, we need to use S. So from the information here, I need to find few answers first. So sum of x over 50 over n. Okay, so I have 10003.3 divided by 50. I have a 200.066. But since this is not the final answer, please try not to simplify the value yet. Then I have s squared, okay, 1 over n minus 1 of sum of x squared minus sum of x the whole thing square over n. Okay, so I fill in my information. So 1 over 49 of 2002665, okay, minus 10003.3 square over 50. Okay, so 10003.3 square divided by 50 minus 2002665, okay, divided by 49. So I have a 27.44 453,469. Okay, or S equals to square root. I have 5.238753162. Don't forget, this is not the final question at all. Okay, now I want to calculate 95% CI for mu. So I use bar x minus 1.96, okay, S over square root 50, comma, bar x plus 1.96 S over square root 50. So I have in all the information, I just plug in accordingly. So 200.066 minus 1.96 plus minus S is 5.238753162 over square root 50 equals to divided by square root 50 times by 1.96, okay, minus 200.066, 198.6 plus 200.066 plus 200.066. I have a 201.5. That will be your answer. Okay, so as you can see, this is what happened when the population distribution is not known. At the same time, the variance is not given. Okay, so we need to apply CLT. Then the last one, okay, for a last random sample size n, a 95% interval for proportion. Okay, so this one we say it as 90. So 1 minus alpha 100% CI for P. Okay, so we use P hat minus Z alpha over 2. Okay, square root of P hat. Okay, 1 minus P hat over N. Okay, P hat plus Z alpha over 2 square root P hat 1 minus P hat over N. So the reason I write P hat here is to telling you that this is a proportion that you found from sample. Proportion from sample. Okay, therefore we write in this way. Okay, so in this question, the questions here write in the form of PS, P subscript S, but I write as a P hat. So let's look at the example. Okay. Okay, let's see. So a large urban area is considering introduce making 2 of the 5 lanes on one of the main roads into the area into high occupancy vehicles lanes at the peak travel times to try to ease travel congestions. Planning officials commissioned a study to estimate a proportion of vehicles currently carrying only the driver. The study recorded 653 vehicles, so N equals to 653. Okay, on the road between 8:10 a.m. to 8:15 on the random selected ordinary working day. Analysis of the video recorded suggested 3. Okay, yes, you have 362 of them. They carry only the driver. So the proportion that we have is 362 over 653. You can see that these two information is strictly from your information that calculate 95% CI for proportion. So 95% CI for P. Okay, so let me crop it, put it on this side. Okay, so I will have 362 over 653, okay, minus 1.96 square root 362 over 653, 1 minus 362 over 653 over 653, comma 362 over 653 plus 1.96 square root 362 over 653, 1 minus 362 over 653 over 653. Okay, and of course in the end you press your calculator. Okay, 362 divided by 653, okay, 1 minus answer times by 362 over 653 divided by 653 square root answer times by 1.96, okay, plus minus 362 over 653. I have 0.516 comma plus 362 over 653 plus 362 over 653, 0.592. Okay, so this interval here actually saying that, okay, 95% confidence that the true proportion will be fall within 0.516 to 0.592 proportions of the total vehicles that actually carry only the driver. Okay, then let's see what anything else. And that's it. Okay, this is the end of your chapter 4. Okay, so what you need to do now is go back to your chapter 4, what is it called, past year, topical past year, and you can start working on the questions. Okay, thank you very much. Stop recording.